Hello and welcome to Maths with Jay. We're going to diagonalise this matrix. So that means we need to start off by writing down the eigenvalues and eigenvectors of the matrix. And we've already done that in an earlier video, so let's just write down what we found. So we found that the eigenvalues were real and distinct. They're different from each other. And we've got the eigenvectors that correspond to those eigenvalues. So let's just write down what we mean by diagonalising a matrix. Now we're looking for a matrix which will only have entries on the main diagonal, all the other entries are going to be zeros, and we'll find that we'll be able to write down A is going to be equal to a matrix P multiplied by the diagonal matrix D, and then that will be multiplied by the inverse of the matrix P. So it's very easy to write down the diagonal matrix. So all we need to do, it's diagonal, so the entries not on the main diagonal are going to be 0, and the other entries are simply going to be the eigenvalues. And I'm going to choose to write them in this order. It doesn't matter which we write where. But having written it in that order, it's then really important how we write down the matrix P. So because I've written down -1 as our first eigenvalue, my first column in the matrix P has got to be the eigenvector that corresponds to that. So that's going to be the eigenvector 1, 2. So the other eigenvector that corresponds to 8 is going to be in the second column, so that will be 1, -1. So it's really simple to write down the matrices D and P. And then to write down the inverse of P, we need to write down the determinant. So there we're going to be multiplying the elements on the main diagonal, 1 times -1, and then take away the product of the other two. So -1 take away 2 is going to be -3. So the inverse of that matrix P is going to be 1 over the determinant, so 1 over -3. And then we'll swap around the elements on the main diagonal. So that's going to be -1 and 1 there. And then change the signs of the 1 and the 2. So that's our inverse matrix. But it's going to be a bit simpler to not have so many minus signs. So let's incorporate the minus from the determinant in the matrix. So we simply get 1 minus sign instead of the 4 that we had to start with. So now we're ready to check that we have really got the correct values for P, D and the inverse of P. So let's just write down what that combination is going to be. So multiplying those three matrices together, we get P, which is 1, 2, 1, -1. Then the diagonal matrix, -1, 0, 0, 8. And then the inverse matrix has got a third outside it, so I'm going to bring that right to the beginning. It'll make life easier if we do the fractional part at the end. So it doesn't really matter what order we do this in. But it's going to be easier to just leave the third until the end. So what we can do is multiply the first two matrices together first of all. It doesn't actually matter what order we do this in. So we're multiplying 1 by -1 and 1 by 0 to get -1. And then 1 times 0 and 1 times 8, so that will be 8. Then 2 times -1 and -1 times 0, so that's -2. and then 2 times 0 and negative 1 times 8, so that will be negative 8. So there we've multiplied the first two matrices together, so then let's write down the last one. And then, still leaving the third outside, multiplying negative 1 by 1 and 8 by 2 gives us 16, take away 1, so that's going to be 15. And then negative 1 times 1 and 8 times negative 1, that will be negative 9. And negative 2 times 1 and negative 8 times 2, so that's going to be minus 2 minus 16, so negative 18. And finally, negative 2 times 1, negative 8 times negative 1, so 8, take away 2 is 6. And then dividing everything by 3, we get 5, negative 3, negative 6, and 2. So we do indeed end up with our matrix A. So really this bit here is just checking that we have got the right answer. So we have diagonalized A, so the matrix D is the diagonal matrix, and we have shown that we can write A as the matrix P multiplied by the diagonal matrix D multiplied by the inverse of the matrix P. So remember, the actual hard bit here is the first part where you need to find the eigenvalues and the eigenvectors. And it's really important that once you've chosen how to write your matrix D, that your matrix P has got the columns in the same order that you've written the eigenvalues in your matrix D. If you had wanted to, you could have written the matrix D with 8 in the first position and negative 1 in the lower right-hand corner, but then your matrix P would have had the columns the other way round. The first column would have been 1 and minus 1, and the second column 1 and 2. And that would be another way of diagonalizing the matrix A. Having done this, we can now go on and do other calculations. For example, we'd be able to very easily raise A to a power.